Hello guys, welcome to another day of solving LeetCode problem. So today we are going to be tackling problem of solving um, so the sorted array problem, right? Find the median of a sorted array problem. So the equation states this is a LeetCode problem given two sorted arrays num1, num2 of size m and n respectively. Return the median of the two sorted arrays. The overall runtime complexity should be O log of n plus 1, right? And then we have the examples here. So I just went ahead and copied all of this into my IDE so we can read directly from there. So the example one says, so the inputs will be num1 equals to that, num2 equals to that, and so the output would be 2, and then the explanation say merge array 1, 2, 3, and median is 2, which is the middle, right? So there are a couple of ways of approaching this, but essentially right off the bat, you realize that basically you are supposed to be able to merge the arrays. So merge the two arrays into a new sorted array, and then we will find the median, right? Okay, so first of all, we are supposed to merge the two arrays. So I think finding the median, there are going to be two types of ways of finding the median, right? If the length of the two sorted arrays is a positive, right, then the median will be two numbers, the addition of two numbers divided by 2. However, if it's a even number, sorry, if the length of the new sorted array is an even number, then the median will be the addition of the two middle numbers divided by 2, as we see here. If it's an odd number, then the median is just the middle number, right? So how do we sort this array, right? So first of all, let's create the new sorted array. So it's going to be int number, int of meshed, let's just call it meshed, equal to new int, right, nums1 plus nums2, yeah, since the length plus nums2 dot length. Yeah, so because the new length of the new sorted array of the new array, the length of the new array is going to be the combined length of the individual arrays, right? So have that. And how do we want to put it? How do we want to sort this number, right? Now, which approach can we use? So we want to go for each, so we want to iterate this. Now, because we can always have two arrays, and the arrays can be of variable length, as you can see in the constraints here. The constraint says the arrays of num1 and num2 are of different length, which means that they can be the same and they can be not the same. They cannot be, they can be unequal and they can be equal, right? So if we choose to iterate, because we are supposed to iterate, if we choose to iterate one of them and then check on the according to the other one, then we'll have that problem of, you know, the finding out of index problem. And also at the same time, we also need to be putting the least number we find into this. So the idea I'm having is rather we should iterate the meshed array, right? And then at position meshed of I, so at each position of I, we find, we compare let me see, we take the variable, we take the element, so compare the element of string of array 1 against the elements of array 2. Now, so in essence, I'm saying that we are going to iterate, we are going to iterate this new one, and every time we are at an index here, we are going to take a number from here and we're going to compare it against all of these numbers in such a way that I think we're going to do that if this number is greater than, if the number from here is greater than this, the number at this at any index that we're comparing from here, then we want to take this number and put it in I, and then continue comparing the same number which is still at nums 1 to the next number at nums 2. If it is not greater than this, which means this is less, we want to put this one and then come and take the next number here and continue comparing at the number where we stopped here. I don't know if that makes sense, right? So I think that's a better approach. So let me see. So we are going to iterate. So we're going to do for int I equals to 0, I is less than mesh dot length, yeah, I plus plus. What do we want to do? So we cannot use I, because if we iterate I plus 1, then it's a continuous, it just continues. However, this can be out of bound. This will always be out of bound. So what we want to do is use different indexes to compare while iterating once, right? It's definitely going to be a 6 iteration, but we can compare. So nums 1, nums 2. Let me see. In essence, let's check. So I want to do something like int index. Oh no, index equals to 0. Yeah. And okay, no, let's just say index 1. We'll use 2 indexes. Int index 2 equals to 0. Yeah. So that this index 1 will be used to iterate the nums 1 array, and index 2 will be used to iterate the nums 2 array. And we're going to manually, increment them. Yeah. So we are going to do, let me see, we have index plus 1. Will this work? Okay, so the idea is to check. So the idea is to check if the number nums 1 at index 1 is greater than nums 2 at index 2. So it's if, now we want to do greater than. If that's the case, if this is the case, right, because this number is, then it means that this number is less than this, right? Then we want to say nums at, want to now add it to I. So we have to meshed at I is equal to nums 2. Okay, so this is index, index 1, index 2. Yeah, index 2. If you do index 2 plus plus, does it increment within? Does it first of all take the index, then increments it after? I think so. I think so. Yeah. Yeah. It first of all takes the index, then does the increment. So I think this is the same as doing index 2 plus plus down here. Right, so we can just do it in there. Yeah. So we are checking if this is true, then we want to check that, we want to do that. Else, we also want to do if, we want to also check if, is it an if? Well, just like an else here. Else if merge. So if this is greater than this, then we want to put mesh, put this in here, times 2, and this 2 plus plus. That means, but if this is not greater, that means if this is either less than or equal to this, then we want to put meshed I, yeah, something like that. So we want to take rather the meshed I, want to take the norms of 1 instead, since 1 is the lesser number or it's equals to this number, and put it inside the, yeah. But if it's equal to, then doesn't really have a problem. You can put anyone, so you can just choose anyone. So yeah, this is still correct, right? So we also have to check for the next, because if so we check, so let me say we get the first value is going to check across. So if the value at the array number of 1 at norms array 1, norms 1 array, sorry, is greater than the value at norms 2 array, then we're going to put norms 2 array here, that's correct. Else, then we're just going to put norms array here, and even if it's equals to, it's okay. But then we have to check for out of bounds. Out of bound. I have to check for out of bound. I think this should work. But let's do system.outprint. Yeah, so let's just do that. We'll just return something, return a number, return 0, just to avoid the error. And then we're going to test it. So yeah, I already have some variable defined here. So we have 1. So if we sorted it well, the array should be 1, 3, 4. Yeah, so I think there's an out of bound for length of 1. Okay, so I'm thinking that, so one of these, okay, what's happening is that, so one of these it iterates, right? And then it finds a value out of bounds 1. So we need to check and make sure that you only do the comparison you only add when there is an equal to. However, if one of them is finished, then we just take the remaining array, the one that is left, and add it to the array, I think so, which is still within the loop. So if greater than that, we can do, we can check here if this only works if, we can check the length. If the indexes, right? So because the problem I think is the indexes. If the indexes is, yeah, I think even the autocorrect realizes that the indexes dot one, index one dot length. So if index is less than that and index 2 is also less than, yeah, so it's the same thing. So that only works if this is the case. Right. And then now, if it is not the case, say both of them, or at least say one of them is shorter, then we want to take the other one. So how do we figure out? Do we do an else if? I think an else if would do. Else if. So we have to do index 1. It's less than nums1 dot length. Yeah, we can just do that. The nums2, the nums1 is the longest one, right? The longest string. But it is still less than that. Then it's the one that is left to be added, I think. Yeah. Then we can just do index 1 nums1. Then we need to just add nums1 to that. So it's basically maintain the same thing. And then else, so we can just, so if the else here, we can just add the second one. Merge I equals to 2. Because if it is not this one, if this doesn't pass and this is not the longest, which means that this is probably equal to or greater than, then number 2 is definitely it. Right? That's if it's still going through. And so if we do it and we run it again, I shall have the same number there. That's good. Now we are able to merge the array. So if we do 1, 2, then we should have 1, 2, 3, 4. Yeah, there we go. Then we can now find the median, right? Which is basically if norms. So basically if norms, no, if merge dot length modulus 2 is greater than 0, then the median will just return meshed. Yeah, so basically just divide by 2 and return meshed. So we're going to return the number at the center of this. So if this is an odd figure, then we return the number at the center. Else, we'll simply just return, right, the addition of these two. So basically, you return meshed of meshed divided by 2, it should be 2.5. It should be, so you take 2 mesh.length plus mesh.length minus 1 divided by 2. Yeah. Wait, certain. Sorry. Is that okay? So let's check that out. So that should give 2.5. Yeah, let's go. It's true. And so we should have, oh, no, that will give an error. 3, yeah, 3. Should have 5. I should stick with 3. And 2.5. Yes. Yeah, I think that is it then. So let's take this and compare our solution to, yeah, this. Okay, test case 1 pass, test case 2 passes. Let's attempt to submit. Error. Internet connection is down again. Yeah. Exactly sure what's happening. That's good. That's good. So, yeah. So it ran. Oh, our solution is actually really good. Yeah. 51 bits is 1 for this percentage. Bits. Then let's see. Can we optimize this? Can we optimize this? Let me see. Yeah, let's try to extract these length values because they appear multiple times. Let's extract them to variables, replace all 3 occurrence. So nums1 length, and then we're going to extract this one too. Occurrence nums2 length. If this meshed length does it occur multiple times? Extra variable. Yeah, so that's meshed length. Yeah, so that's cleaner. That's much cleaner. Okay, so But there is something that I think it's interesting, because since we're finding a median, we don't need to traverse the entire string, right? We don't need to sort everything. So that's interesting, because if we don't need to sort all the strings, we only need to indicate where to stop. Then that's going to help a lot with the time complexity of O. Is it O or something? Yeah. Yeah. O log of minimum of n plus one, n plus n. Let's see if this does any change. Oh yeah, it does. It does that. So that is really good. That's really good. So yeah, that works. That works. The time complexity of a new solution is perfect for now. I think it beats 100%. That's good. However, the memory is large, so there's that. But yeah, time complexity is what we're concerned about. So yeah, that solution works, and yeah. So that's our solution, and this was great. This was good, and it's a hard one also. So all right, so this is what we have, and I will see you in the next class. Since this is really good, at least I think this is the best, one of the best optimized version of it. But let's see, do we have some other, the recommended lead code one? One second. Yeah, I hate these ones. These ones are so complicated. Margin pattern left. Anyway, so you can just pause the video here and try to understand the recommended solution. Right? All right, then like and comment, and see you in the next video.